So I've been doing a bit more assessing of this output stage for this Wen HR30, trying to fathom out this mess here and how it what we actually had in there before. Now I've been looking at some pictures online of these amps, but I think this is an older model, because there is some images of chassis and in what's going on inside the others, but they're a different model, a newer model. This is an older one. So I'm wondering how they originally had that electrolytic on there. And then I spotted those two holes there, which I didn't really see on the camera. You can see them there. And I thought, well, they must be something to do with it. And then suddenly it dawned on me, and I had a bit of a brevet round in my stash of bits and bobs, and came up with this. So this is a 25mm H1 capacitor clamp, and if you look at those two holes there, they perfectly match those two holes there. So that is where the original capacitor was. I've got the board raised, so that's why that's touching. So then the next thing is we've got to find a dual capacitor, so 47 plus 47 really we want. I've no idea what was in it before, can't get to know, there's no schematics. I would guess round about 40. All the capacitors that I can find that would fit in there, the only dual one was 33 microfarad. So I kept trawling the net, and eventually I found one on a website in America, in the States, and it's a 50 microfarad 50 plus 50, 500 working volts, and it's 25mm wide. It wasn't cheap, and the postage was $40, but it's coming to UK. But having said that, that wouldn't be perfect in there. So we can get rid of this trash, put that in there, and it'll, not only that, it'll be like it was when it was original. Just sheer luck that I'd got this. I could have bought a new one for it, but it's just nice to have one where the patina matches the amp. So we've just got to find a nut and bolt to go through there. And again, I need to find, I've got some old nuts and bolts where I've stripped things down, so use that, try and keep it looking reasonably original. So I've had the board out, and I'm actually doing a schematic for this. I'm tracing it out. So this amp's got 4 cathode resistors, one for each tube. So we've got, if we hone in, so we've got cathode resistor, bypass cap, cathode resistor, bypass cap, and then if we go over here, we've got the same again and the same again, and I have traced them out, tested, and they are separate. So that's interesting, something you don't often see on amps. Lifted this board, so I'm just gonna turn this round. Check out that, by the way, what they've used to cover off those when they've changed those sockets on the back. So it looks like a business card or something, that half a business card, so we may have to find something to go over that. So yeah, back to the underneath this board. So if we lift this board, we've got some work to do under here, and if we hone in again there, you can see we've got the dreaded green rust on there, whatever. So if we'll just go down, so you can see, looking in there, so you can see that there's a fair bit of cleaning to do on there, but with that we can get that cleaned up there, it's no problem. So we've got that to sort out, and so I did some testing through on this. We've got a blown screen resistor, so that'll explain some of us low volume. The screen resistors are 100 ohms, and there's 4 of them. They're only 1 watt, and one of them is blown, madam. So honing in on him, he measures 2.7k, and I think that is 180 ohms. And I've traced out most things, so plate resistor there, sorry, there you can just see him hiding down there, plate resistor there for the phase inverter. That 56k that you can see there is for the is on the cathode of the phase inverter, and the cathodes are joined together on it. The 10k's you can see here, they're grid stoppers for the sorry, where are we? Let's go back that way. I've got it zoomed in that far. 10k's, these 10k's you can see, there's another one there. They're the grid stoppers for the output tubes. These 470k's are the grid leaks, I'm pretty sure. There's two of those, the other one's on the other side of there. That's the smoothing cap for the phase inverter. And we've got a cap here which is 0.1, and we've got another cap here. I'm not sure what value that is at the minute. Looking down there, sorry you can't see that there, that's it, that mustard cap. So obviously, and there's another mustard cap there, and I think is that that might be 2200 picofarad. So I'm not sure what they're doing. That seems a bit low for coupling caps for the output stage. And we've got that 0.1 there as well. So I've got to find out just got to trace out what they do. And while we're on the subject of looking at things, check out this for botch. So those there that you can see, they are the speaker leads, and look how badly they've been soldered, and it is a miracle they aren't touching one another. That would have been probably goodbye output transformer. How can you solder that bad? That is shocking. Let's see how close we can get in before it goes out of focus, and you can really see there. So they have been seriously botched. So we've got to sort that out. It's no job to sort it out, it just bemuses me why people do that. So that is another job, but the board's got to come out anyway, because I've decided with this board I'm just going to go through it and change all the components, majority if not all of them, because majority of them have got to be changed anyway. There's some out of tolerance resistors and various things, so I'm just going to go through it, and it's just quicker. Just take everything, just go through, change everything, and just redo it, so it's like a brand new board. And you get rid of some of this rust on the chassis as well. You can see there now, if I zoom in, you can with this now, because I've got the zoom on this camera, I found the zoom control and added it, so we can see that. So there's all that to clean off, and then obviously I'm just going to turn it over, and then if we look at this chassis here, and if we zoom right in, we can get right in there, and you can see there's quite a lot of rust on there, so we've got to clean all that off as well. And you can see it, sorry, let's try that. So all that rust there, we just back off, and you can see I'm enclosed there, so you can see there's a lot of stuff to clean up there. Now if we hone in on these resistors here and capacitors, I can see 4,700 picofarad on those mustard caps, and they'll both be the same, and 2.2k on those resistors, which are very, very corroded, so they've got to be changed as well. So we're going to remove those. If we go on to this transformer, which incidentally I'm still not 100% what this transformer is doing, it is linked to an outlet, but there's nothing from the preamp connecting to that outlet, so I don't really know what that's for at the minute, till I've got the meter on it and had a bit of a test. I don't really know, but you can see again, if we hone in, you can see some crappy solder work on those, so we're going to sort all that out, because even though that's not being used, it still wants putting right. Can't leave that like that, just looks dreadful. Right, I've done some more work on this WEM, on the output section, and you can see I've completely restored this board. Numerous components that were either blown or out of spec. These individual cathode resistors were all out of spec from and out of spec from each other, obviously, so I'm trying to get those as close as we can to 270 ohms. The screen resistors, one of those was blown, and I've upped those to 2 watts, and I've lifted them off the board as well. So I've got that in there. I've got most of that done. Now there's an issue here with this foam, and you can see it crumbling away. Now what they've put that on there for is to just cover those screws, which is a bit of a crude way of doing that, really. So what we're going to do is, we've got some of this, you can see the thickness of that. So what I'm going to do is I'm going to cut a strip of that out and put it underneath sorry, just lost that, to make sure that's safe, because I don't like that. That don't look safe to me, and we could have issues with that. So we're going to do that. And now with this one of these screen resistors being blown, it means that there's obviously been some excessive current somewhere. So what I am wondering is if one of those Mullard valves has got an issue. I rather hope not, but that resistor just went blown. It was also black. It had had some heat, so it had had some current. So that's a bit of an issue as well, and we won't know until we actually put this together. So what I'm going to do is I'm going to put this together, and then I'm going to run it up again before I restore the preamp stage, because we need to make sure this is running okay before we tackle that. Otherwise we could end up with faults on here, faults on there, and then it'll just be a nightmare to try and find out what's wrong. So that's where we are with that. We need to do something with that as well. That's just abysmal doing that. I don't know what we're going to put in there, I'm sure, but that's not very good, so we need to try and do something with that. So the capacitor then, the main electrolytic nodes 1 and 2, so we're going to have a look at that now. So I've spun this round so we can see those 2 holes there, and as I showed you before, this bracket goes there, and that's 25 mil. It actually goes like that. And here's the capacitor that I ordered from the States, and this was the only thing I could find online that would fit this. 50-50 microfarad at 500 volts working, so that's 25 mil. Bit of a downside is it's got the wires on there, which means we're going to have to J-hook that. It's the only way we're going to be able to do it from there, I would have thought. So just drop that. So that's where that's going to go, in that bracket there when that board's down, and that is originally where that went on this particular amp. Now remember, although this is an HR30 Control, this is an older model than the ones you can see online. There is some pictures online, but this has got a very early 3-digit serial number, so this is an early one, and that was fastened there. And the reason I know that for sure is because even the screws line up to this bracket here, lines up perfectly and everything, and that's the only place it could have been, really. Can't see, there's nowhere else it could have been mounted. So most of the caps you find online are 35 mil in diameter, which is too big to go in there, so that's rescued us with that. So these caps are called Holy Grail. Just bring that round. So the Holy Grail capacitor. Let's just hope that it is the Holy Grail, and that in a month's time we don't find a hole in it. So that's that. because I have got no idea on those caps whatever, so it's a first timer. Wasn't cheap to get that over here either, but we've got to do this amp right. We can't be bodging it up with sticking caps in, putting tyre wraps around and things like that. I'm not having any of that, so we've got to do it right. So we're going to get this board back down after we've made that safe underneath. We're going to get this board down, and then I'm going to fit that capacitor onto there. We're going to find a safe way to ground it, and that, of course, that is one concern, is how they actually grounded that, because I don't see any, there's no other holes for tag boards anywhere around here for a tag strip or anything. I suppose they may have wired it to that screw there, so we're going to have to find a way without drilling it to get that ground of that capacitor on there to make that safe. And we're going to have some new diodes. I can't see the point restoring all this and leaving out diodes in that are like 60 years old, getting on for. So that's what we'll be doing. So I want to crack on. I've left these capacitors, these resistors in here, these 2 1 megs and this, because they test very accurately, so I've left those. But everything else on this board rather blown or out of tolerance, and just no. So that's all been restored now. So I'm going to crack on and get that piece of foam put in there underneath, make that safe, get the board down, and then we can start looking at this capacitor. There's the bracket that we're going to put this main capacitor on, this main electrolytic. Now I found a couple of screws to fasten that on. I save a lot of hardware like this. I think most techs do, don't they? And they've got the right patina and they look right. So we're going to use those to fasten on said item. And there we are. That's how we think that was originally. And it's certainly the best, much tidier way of going on there. And I've actually set it back, and I've done that for 2 reasons. One is I need to get a ground on there, so if you can see that, just holding there, you can see that screw. I want to get on that bolt, I want to get a tag on there so I can ground it. God knows where it was grounded before, maybe on there, don't know. And secondly, you can just read what it is on there. So I put it in the centre, you can't, so it just means if someone comes along and services it again, they can at least see what's in it before they have to take it to bits when they're ordering the part. So just a bit tech friendly there for that. So that's in place. Now we've got to wire it up and make it all safe, because as I said, we'd have preferred a terminal one, but afraid we've got these wires instead, so we've got to make the best of that. But it was the only thing I could find to go in there. I couldn't find anything else anywhere other than this, which I got from the States. Right, we've got this capacitor fitted, and that's how it must have been when it was original. That's the only way it could be. We grounded it down there. We just hone in, you can see. Got the big soldering gun out, got all that done. Now what we've done here, so I've got 2 diodes there. They're 3 amp 1000 volts, plenty good enough for this job. You can see those there. And then if we hone into this, there's a 1.5k resistor there just protruding. So why have I've put this shrink wrap on there. It don't look pretty. They're shrink wrapped individually, the each of the legs, because remember this capacitor has got wires coming out of it, as opposed to having terminals, and more designed for point to point, so we've had to wire it point to point, unfortunately. But I was just a bit weary of this getting back onto this chassis, and that's also stiffened it up as well, adding that to it. So yep, controversial maybe, it don't look particularly great, but it is safe, and that's the most important thing with this. think that's a bit too close to its chassis for my liking. Had that have been on terminals, then it wouldn't have been an issue, but that being as it is, for me, that's the best way of wiring that. Either way, the diodes won't reach to the ends of there where it'll be more secure. Then you've got to start extending out, messing about, then the diodes are floating around. So to me, I've just done that. That's the way I've done it. So basically that now is pretty solid. It ain't going nowhere. Right, we've got it up and running. So what I'm going to do now I've got a set of tubes in it at the minute which aren't its original tubes. And what we've decided to do with these Mullard valves is the guy that owns this. What we're going to do is mothball those Mullard valves, and he's probably just going to use them for recording and things like that, and just keep this pair. Just find him a pair to just a normal quad of tubes. Now the fortunate thing with this amp is we can match up these tubes pretty well, and the reason for that is that this amp has got separate cathode resistors for each valve, and you can see those 270 ohms there's one pair, and then if I go over there's another pair. So because of that, we can match up a quad of valves. Now I'm also going to put those valves in and test them now, those original Mullards, because we had that screen resistor blown. There is a chance one of those valves is faulty, so that's the next thing that I'm going to test. So I've had a bit of a tink around with these Mullard valves, and this one is flashing over inside, causing all sorts of problems. Cathode voltage is disappearing off it, so as suspected, one of these was faulty, which is probably what's blown that screen resistor and caused those problems. But as look at it, through my stash, I've actually found another Mullard valve. Now these, if you probably can't see on camera, but these were yellow print, same as that preamp valve. The one I've got is white print, but again that's faded. So I've added one of them in, so that's made a quad of those. So I'm just checking them now to make sure that they're not massively unbalanced. But yeah, bit of a shame, but I did suspect that, and I did say earlier in this video that there may be one of these valves faulty, and that's what's caused that screen resistor to blow. Right, so I've tested the bias on these Mullards, and starting from this left side, I've got 9.3 on the first one, 9.26 on the second one, so they're really closely matched. 9.02 on the third one, which again is quite close. 9.7 on the last one, which is a little bit over, but they're pretty well matched for a quad of valves, given their age and the fact that I've just added another Mullard in there from the original pair. I think we can be satisfied with that with the Mullards. So what I'm going to do now is find him another set of tubes to go in this. Right, so balance these tubes up. We found a set of 4, and they're pretty close. Let's see what we've got them at. So the first one, this one here, is 8.96. We've got 9.36, 9.24 and 9 watts. So that's pretty close for them. So that's that sorted out. Now what, so he's got his Mullards there, can mothball those and just use them if he wants to, if he's recording or something, and they're just a nice set of tubes to have. So that's that. Now then, what's left on this? I've got that blanking plate I've got to fit, which I've made for that, so that's more professional, because remember we had a bit of credit cards something stuffed in there, I'm not sure what it was. Now the other thing are these in here, and I'm just going to zoom in, and you can see those resistors, and there's also the capacitor there, and the problem I have with this is it's a little bit dangerous. Got to be a bit careful when changing those valves and make sure this amp is unplugged and the caps are drained. So I'm kind of looking at that, wondering if we can make that safe or not. When I've replaced these resistors, these are on order, these resistors and these capacitors, they're on order. They look like they've had some hammer, so I'm going to change those. So I'm looking at a way that I can possibly make those safe. So I'm hoping to come up with something for that. Bit of soldering to do on there, because that, as you can see, that's, I think we've looked at that before. It's a bit botch. Other than that, that's done. So now we're going to focus on this preamp. We just hone out with the zoom. Just move that cable, and you can see that there's a lot of components on there to sort out. So we just go across. We've got 5 tubes on there, so we've got quite an array of capacitors and stuff to look at. And then up on top we've got the module there. So yeah, a lot of stuff on there, and of course we've got to get that board out, strip it down first. So that's what we will be seeing in part 3. As regards part 2, which is this part here, the output stage, I think we'll wrap it up at that, and I'll see you in part 3 when we're starting the preamp section. So please subscribe to the channel if you wish to do so, and you all take care, and I'll see you in part 3. Take care, bye.